Okay, continuing on with section 1.2, we are going to talk about domains and ranges of functions and express them using the interval and inequality notation that we practiced in the last video. So just to review, if we've got a function goes from a domain to a range, right? You put a value from the domain into the function, and out comes a value in the range. So we could look at a graph like this one. Looks like it has a little circle right there. So it ends at that point, but it looks like it has an arrow here, so it goes on forever. So the domain are the values on the x-axis that the function is defined for. So it looks like, so this red line here is indicating the domain. It looks like it's going to start at -5. The domain is going to start at -5 and go on forever, right? And the range is going to, let's see, the highest it's ever going to get is 5, and then it's going to go down forever. Oh, wait. So how would we write that? How could we write that down? So the domain is going to go from -5 to infinity. So the domain is going to go from -5 to infinity. Does that look right? I have a curved bracket by the infinity. I put a curved bracket here by -5. But if you look, it looks like -5 is included. So this should actually be a closed bracket, right? Because -5 here along the axis would be included. All right, so the domain is going to look like that. How about the range? What's it going to look like? Let's see. So it goes, this is the kind of tricky part. For the range, we always start we go from the bottom of the y-axis up to the top. Okay, so at the bottom of the y-axis is going to be -infinity. We're going to go from -infinity up to 5. Okay, so when we write that down, we're going to go from -infinity, comma, 5. And let's see, does it have a closed bracket? Yeah, it includes the value 5 on the y-axis, right? So we're going to want to put a closed bracket there for 5. All right, let's try another one. Why don't you pause this and then come back and we'll do it together. Okay. So on this function, the domain is going to go from -3 to 1, right? And this is open circle because -3 isn't included, and this one is a closed circle. So the domain is going to go from -3 to 1, and that's a closed circle. And let's see, the range is going to go from -4 up to 0. Is 0 included? Well, let's look. Are there any values with 0? Here, this one is open, so that one's not included, but here's another one that is included. So even though that's an open circle, this is a little bit tricky. There is a 0 value in the range, right? So the range is going to go from -4 to 0. -4 to 0 with closed brackets like that. All right, here's a real life example, which I actually thought was kind of interesting. Alaska crude oil production from 1970, whatever, up to about 2010 or so. It really peaked around 1990 and then has been decreasing. And I was curious, so I just Googled it, and it looks like it continued to decrease since then. So I wouldn't have guessed that. So let's think about what's our domain and what's our range for this real life problem. Well, our domain is going to start, let's say, like 1973, right? And for this graph, we could say it's going to go to about 2010, right? The x values it's defined for. In real life, it's going to go on indefinitely, right? Maybe it'll go up again, maybe it'll go down to 0, who knows? And how about the range? Let's see, it looks like the smallest that it was maybe 180 up to about 2,000 thousands of barrels per day. So let's see, that would be 2 million barrels per day. So let's see, the domain is going to go from 1972 to infinity. And I don't know if this should be curved or square bracket. It's a little bit hard to with an applied problem like this. But let's look, the range is going to go, let's say, from 180 up to 2002. And we're just estimating there. Let's say inclusive. Okay. All right. Here's another one we could look at, world population increase. Okay, so it looks like the domain would go from about 1950 to 2000, probably inclusive. And the range would go from, I don't know, let's estimate 48, right, the y value here, up to about 90. Right? Okay, so now let's look at the toolkit functions. You can pause for just a minute and think about each of these, and then the next slide is going to say what the domain and range are for each of these toolkit functions. Here we've got a constant function. Okay, the domain, what x values is this defined for? And what y values, what's the range? What y values is this defined for? The domain is going to be defined for anything from negative infinity all the way up to infinity along the x-axis. But what's the range? The range is just the c value, right? That's the only y value that this function has any output for. How about this one? What is this toolkit function? This is y equals x. What are the domain and range? All real numbers, right? For both, the domain is negative infinity to infinity. The y value, the range, is negative infinity to infinity. What's this? What toolkit function is this? This is absolute value. Domain, all real values, negative infinity to infinity. The range is going to go from 0 to infinity, and it includes 0, right? So that's a square bracket there. How about this one? What function is this? That is x squared, right? That's a parabola. Domain, negative infinity to infinity. Range, 0 to infinity, inclusive of 0. All right, how about this one? What function is this? That's x cubed. Domain, negative infinity to infinity. Range, negative infinity to infinity. What's this one? This is the reciprocal function. And the domain is almost all real numbers, right? But it doesn't include, there's a asymptote here. It doesn't include 0, right? So the domain, we're going to have to use this union notation, right? From negative infinity to 0, 0 to infinity, with curved brackets there because it doesn't include 0. And the range is going to be similar. How about this one? This is 1 over x squared. Domain, similar, all real numbers except for 0, right? So we need to use the union notation. And the range is going to go from 0 to infinity, but not including 0, right? So it has a curved bracket. What's this? Square root of x. Domain is going to go from 0 to infinity, inclusive, right? Has a square bracket. And the range is also 0 to infinity. What's this one? This is the cube root function. Domain is going to be all real numbers, and the range is all real numbers. Okay, so that's using graphs. Now let's say, okay, what if we have equations? What are the, what's the domain and range of an equation? Okay, well, let's start with this example 8 up here. Find the domain and range of f of x equals 2x cubed minus x. And it says domain and range. We're really interested in the domain at this point. Okay, so let's just find the domain. This is a polynomial, right? So one thing that's good about polynomials is the domain is always all real numbers, okay? Because there are two issues for domain. Can you think what they are? Things that can't happen. One is we can't divide by 0. Okay, and the second is we can't take an even root of a negative number if we're talking about real numbers, which we are for now. Okay, those are the two things we need to be concerned about: dividing by 0 and taking even roots, like a square root of a negative number. All right, so let's look at example 9. Find the domain and range of this. We don't have any square roots, so we don't have to worry about that, but we do have a denominator, and we can't have the denominator equal to 0. So how do we figure out what the domain here is? Well, we can't have this equal to 0, so we have to figure out where is it equal to 0. So we need to take that denominator and set it equal to 0, and then solve, which isn't too tough in this case. We get x equals -1. Is that our answer? No, the question is asking, what is the domain? Okay, well, this is what has to be excluded from the domain. It's everything except for -1. So if we're going to write it using interval notation, let's say, we're going to go from -infinity to -1, and then go from -1 to infinity. How about in this case? Example 10, find the domain and range of this function. Again, let's just worry about the domain for now. We don't have any denominators, so we don't have to worry about dividing by 0, but we do have a square root. And we can't, so what we need is this to be not negative, right? So let's write this down. We need the radicand, that's what this thing under here is called, the radicand x plus 4 to be greater than or equal to 0. So we solve that, and we get x has to be greater than or equal to -4. Is that our answer? Actually, yes, that is our answer in this case. We could keep it like that in using inequalities, or we could write it using interval notation. Let's see, greater than or equal to -4. So we're going to start at -4 and go up to infinity. And here's a graph of that function. Okay, so we can see the domain is going from -4 to infinity, and we could say the range is going to go from 0 to infinity. Okay, so that's how, looking at graphs, we can find domain and range, and looking at equations, right? The two things for equations are can't divide by 0, can't take the even root, like the square root of a negative value.